Hello friends, welcome to my channel Sky is the Limit. In this video, we shall discuss about acceleration due to gravity. So what acceleration due to gravity states, acceleration of a freely falling body due to Earth's gravitational attraction is called acceleration due to gravity. Suppose an object is moving in this direction. Certain amount of force is applied on this object. So because of the force applied, what this object do, it will start moving, right? It will start moving with certain amount of velocity. At every point, the velocity will keep on changing. Since the velocity is changing at each and every point, the rate of change of velocity will give you what? Acceleration. So this acceleration is produced because of the certain amount of force, external force applied on the object, right? So that is known as acceleration when the object is moving linearly, that is moving on a horizontal path, okay, not vertical. Horizontal to the earth, if it is moving, then we say only acceleration. Now what is the difference between acceleration and acceleration due to gravity? Acceleration due to gravity is nothing but the force applied by the earth on an object, okay, and it attracts the object towards itself, and the body will move under continuous changing velocity, and that changing velocity will give rise to the acceleration, and such acceleration is called as acceleration due to gravity. Suppose we have an object which is under freely falling, okay, it is freely falling, and we apply the earth applies certain amount of force on the object. This is our earth. What earth do? Earth will apply certain amount of force on this object, and the object start accelerating. The object moves under continuous changing velocity, and since the velocity is changing continuously, we say that acceleration comes into act, and that acceleration is provided due to the Earth's gravitational force. So that is the definition of acceleration due to gravity. Acceleration of a freely falling body due to Earth's gravitational attraction. The Earth is providing certain amount of attractive force towards that object. Because of that, the object is accelerating, and that acceleration is known as acceleration due to gravity. After understanding what is acceleration due to gravity, it is necessary to understand the relationship between mass and the weight. We have mass and weight. So what is the difference between mass and weight? In our daily life, what we do is we conveniently interchange both mass and velocity, but mass and weight. But mass and weight is continuously completely different things, okay? We should not compare mass and weight together, since mass is due to the inertia and weight is due to the acceleration due to gravity. Let us understand it in detail. Suppose you have one object and you apply certain amount of force on this object. So what this object do? This object will start moving with certain amount of velocity, right? Once you apply force, the object will start moving with certain amount of velocity. Since the velocity is changing at each and every point, changing velocity will give rise to the acceleration. Now suppose the mass of this object is m, and this mass is nothing but give rise to the inertia. What Newton's first law of motion says, that every body continues to be in the state of rest or in motion unless and until an external force is applied on it, right? So the mass is nothing but it is due to the inertia. Now suppose you have, due to the force is directly proportional to the mass of the object and acceleration. Now from this we can write A is equals to F by m, right? This is an important relationship. Now suppose you have two mass. Suppose you have two mass. This is small m1, and we have a big mass, that is m2. An equal amount of force is applied on both. The force is same, okay? This is F, but the masses are different. Now what happens? Since the mass is different, you will get acceleration as force by m1, and for this it will be a2 is equals to force by m2. Now from this equation we can say, as I have told, that mass of m1 is less than mass of m2, right? m2 is having more mass. If suppose this m is increasing, that means if m is more, then m2 is more, then a2 will decrease, right? m2 is more, so therefore a2 will decrease. Here m1 is less, therefore m1 is less, so therefore a1 will increase. From this we can conclude that if the masses is heavy, then its acceleration will decrease. If the mass is lighter, its acceleration will increase. Hope you have understood this. Or you can also relate as more mass, it gives you less acceleration. Hope you have understood this. More mass, it gives you less acceleration, or we can say more resistance in change in inertia or state. So what does it mean? If it is more mass, then the acceleration is less. If the acceleration is less, we can say more resistance in change in the state. So you cannot easily change the state of the object, okay? You need to apply a lot amount of force in order to change the state. Hope you have understood this relationship. That is, if the mass is heavier, then acceleration will be less. If mass is lighter, then acceleration will be more. Then let us consider we have an object of mass m and the force is applied in this direction. That means it is freely falling under gravity. So therefore earth is applying some amount of force on this object. So therefore this force will be force of gravity, we can say. This is very important topic. You need to listen it very carefully. Suppose there is a mass m, and with suppose the force applied by the earth is F. Now what this mass will do, it will move towards the earth, right? The body is under free fall. Now what happens? Once it is moving, it will move with a continuous changing velocity. Since the velocity is changing, there is acceleration, and that acceleration is known as acceleration due to gravity. So therefore we can say the force is directly proportional to mass of the object and acceleration due to gravity. This is very important relationship, that is F is equals to ma. Now here this force F is equals to ma is nothing but the weight. What is it? It says you about the weight. What is the value of G? G is 9.8 meter per second square. This is acceleration due to gravity, and therefore the force when the body is freely falling, then we get F is equals to ma. This is very important relationship. Now suppose if the object is moving under free fall and it comes to the rest, okay? If suppose a body is residing on earth, does it mean that there is no acceleration due to gravity? Whether earth is not applying any force on this mass? No, the earth is applying force on this mass, but it is not moving. Why it is not moving? Because as it touched the surface of the ground, earth, what happens is, due to Newton's third law of motion, the earth will apply same amount of force, the object will apply same amount of force on the earth. That means equal and opposite force, and that force is that force is known as normal force or normal reaction. And the weight of the body is mg, and this is the opposite force, that is normal force. So therefore we can say these two forces will balance out each other. Okay, we have the normal force will be equal to mg. Hope you have understood what is weight and what is mass. Mass is due to the inertia. Okay, mass is the measure of inertia, and weight is the weight is when the body is under when there is acceleration due to gravity acting on it. So therefore we can say what will be the main difference between mass and weight. Suppose you are on the earth at this point, and here. Okay, you are here. Your mass won't change at each and every point on earth. The mass will remains constant, but your weight will change. Why the weight will change? Since we know F is equals to ma represents weight, and weight totally depends upon acceleration due to gravity, and acceleration due to gravity changes at each and every point on the earth. It have varying acceleration due to gravity. Earth is not having constant acceleration due to gravity at each and every point. It is different at the equator and it is different at the poles. So therefore we can say mass of the body remains same at every point on the earth, but the weight of the object continuously changes. Suppose if you are on the earth, your weight will be something different, and if you are on moon, your weight will change. Why? Because acceleration due to gravity of moon is different, g of moon is different, and g of earth is different, and g of space is different. So you will weight different on moon, space and earth. Hope you have understood the difference between the weight and mass. Therefore we can say the difference between the mass and the weight as the mass is the quantity of matter. Suppose this is your object. The amount of matter present in this is called as mass, but the weight is the gravitational force with which the earth attracts object towards its center. Then we can say mass is the scalar quantity and weight is the vector quantity. Since acceleration is a vector quantity, acceleration due to gravity, so therefore we can say weight is the vector quantity. Then we have mass is constant at everywhere in the universe. Mass does not change from place to place, it is constant everywhere. But weight, what happens in case of weight? Weight of the body is variable. The weight of the body depends on the location. Then we have mass of the moving body is given by m is equals to F by A, and for weight of the body is given by W is equals to mg. Unit of mass is measured in terms of kg and weight is measured in terms of Newton. Why? Because it is the force, right? Weight is nothing but the force. F is equals to mg. So therefore unit for weight is Newton and unit for mass is kg. Hope you have understood the difference between mass and velocity. Then we will understand what is the relationship between acceleration due to gravity and acceleration due to gravity, and the relationship between acceleration due to gravity and capital G. This is very important relationship, and this relationship will ask for 3 marks in any exam. If it is GPSTR or any competitive exam, and there are descriptive answers, then this question is for sure it will be asked for 3 marks. So see, if suppose you have earth and mass of earth mass is me, and there is a small body of mass m which is on the surface of the earth. If this is small m, which is located on the surface of the earth, and re is the distance radius of the earth. So what we have a earth of mass me object which is placed on the surface of the earth of mass small m, and the radius of the earth is re. So therefore we can say the distance between the center of earth and this body m is re. Therefore from the Newton's law of gravity, what we have, the relation F is equals to gm divided by re square, that is universal gravitational constant, and mass of the earth, mass of the body, that is small m, mass of the body, and the distance, square of the distance between them. Then from the gravitational force, we have gravitational force, that is weight, that is equals to mg. What we have F is equals to mg. Suppose this is equation 1 and this is equation 2. From equation 1 and equation 2, what we can say, from 1 and 2, we can say that mg is equals to gm em divided by re square. So from here this m get cancelled. We will get g is equals to gme divided by re square. This is very important relationship between small g, that is acceleration due to gravity, and the gravitational constant capital G. Hope you have understood the difference between mass and mass and weight, and the relationship between G and capital G. Here you can see the complete derivation between acceleration due to gravity and gravitational constant capital G. You can take the screenshot for your convenience. Then you can see the difference between mass and weight. Then next we have weightlessness. In the next coming videos we will be discussing about weightlessness and the remaining concept of gravitation. For more videos, subscribe to my channel and hit the like button and share with your friend.